Okay, hi everyone. Welcome to our third online session. So today we're going to be working on exercise 5.1, and if we have time, we'll move into exercise 6.1. So let's begin. As always, these sessions are meant to help you. So please use them to ask questions, even if they are beyond the session content. The idea is, of course, to help you and guide you through your experience learning R or improving your R skills, or and so on. I've noticed a lot of people have been using the discussion forum. I think that's fantastic. This group has been, I think, the most active that I've seen on the discussion forum. And I think it's been pretty fun for me to go in and answer some of the questions. And I know our teaching fellow, Ray, has also been going in and answering some questions. And I've seen even you answering questions of your classmates. So that's wonderful. That's a great type of community to build and support that's available. And so I hope you've been finding that helpful, and feel free to use that. The benefit is that everybody gets to see everybody else's question and the answer. So, but I also been getting emails and other things. So I'm responding to those as well. If I've missed yours, I'm pretty good about it, but just send me another one. Okay. Everybody has a lot going on these days. It's a busy time of year. So if I've missed an email, like, please just send me a gentle reminder. But I don't think I have, but just checking. Then the second bullet point gives you an opportunity to practice. So I want to make sure that you're actively working in our studio during these sessions. It's supposed to be less of a lecture and more kind of like a workshop where I do some demonstration, you try to answer the questions. And then finally, another forum for you to, like verbally ask your questions, ask them in text chat as well. So let me open it up to the question part. Is there anything that that's on your mind?
I have a question. So I do a lot of like ETL stuff at my day-to-day tasks, right, for data. And I was just curious. I mean, I see a lot of, like, I'm immediately seeing a use for a ton of this stuff, so I'm looking forward to that. But is there like a general limit that you find? So Excel starts to get weird at whatever, 1 million rows or something, where you find that even R starts to get maybe a little bogged down or starts to run into problems in terms of like the size of a data set?
Oh, okay. Great question. So definitely if it's running on my desktop, right? And so this is where, so R is a platform that then can be installed on, any kind of middleware. And so we have a big data cluster at Stern that instead of running R on my desktop, I would SSH into my R instance and use it from there, and use Hadoop to process like the calculations that I run on my data, for instance. Does that make sense?
It does, certainly. Thanks.
Yeah, sure. And I mean, there's also like another way to look at like limitations or like why use one or the other. It could just be that like the model that you want to use is not as good, is not as well developed for R as it is for say Python or something, or vice versa. And so in Excel, like there's different ways that we can model our data in Excel, let's say using regression models. But when we get to something maybe more complicated, we want to do some type of clustering, that's where like I'm immediately going to R and using those different data mining packages. Good question. Any other questions? All right, wonderful. Feel free, as always, to ask them along the way. So I don't have too many, slides or anything for you on graphs in R, because you're going to get a whole class in it. I think a day and a half in Shanghai. on data visualization and a lot of prep beforehand in my course. But I want to give you some basics with regard to graphs in R and how we then format our graphs in R so they look decent. And I'm curious, just like you could either just by saying like Y or N in the text chat for yes or no, like how many people have gone through session 5 and created some visualizations? Yeah, and so if you have, wonderful. But I wonder if you were surprised or surprised at the presentation of those visualizations. Did they look a little, uh, for lack of a better term, like they were built in 1980? 1960s for Sanjeet. I love it. Right. And so we're going to try to get out of the 60s or the 80s because there's a lot we can do with the packages in R. And I mean, of course, we're starting with the fundamentals. So um, I think I didn't want you to think that was lost on any of us at all. Okay. So but the cool thing is that you're able to, at this point, visualize in R rather quickly. So I'm going to go, and the code is so long, right? So the cool thing that we can do with some of the code is that we can actually, if we repeat things a lot, those things that we repeat a lot, we can store in a variable or a function, in the future. So we'll make ourselves a little bit more efficient. That's not to worry. Okay, so let me bring up a few points about graphing in R. So these are just points that I'd like you to consider. So the role of visualization is what? Is that you're using visualization to help understand your data. And visualization should be self-explanatory and really make that process of interpreting the results of the data very, very clear. And so when we use visualization, we use it for two reasons. We'll use visualization to explore our data. So we may have a data set, we might want to just have a histogram so we can see a little bit about the frequency distribution, or perhaps we might want to show a box plot because we want to look at the range, right? We want to see the max and min values, we want to see the median and the interquartile ranges. We might use a scatter plot to see if there's any kind of correlation or relationship between two variables. And so all those are really tools for exploration. And then when it comes time to for presentation, that's a second use of visualization. So I'm going to write that in the text chat that there's really two. Excuse me. So the first one is exploration, and the second one is presentation. And this should kind of make sense to you. Of course, like the work that you're doing in portion of this course is all for really exploration. None of the graphs that you're probably creating as part of the exercises are going to be, what we call presentation ready. And I think you would agree by just visually how they look. So one is that like part of the presentation is that we want a good aesthetic. We want to make sure that it matches, say, with the style of our presentation, that we avoid using unnecessary non-data elements. Non-data elements can be known as tick marks or grid lines or extra text that doesn't really add or contribute to the insight. And so we try to remove those non-data elements. Because if you're thinking of a histogram or if you're thinking of a box plot, the histogram, it's those bars are the data elements, but it's that axis, that x-axis, for instance, that's a non-data element, or how that x-axis is labeled, or the title of the graph. All those things are extras that aid or hinder in the interpretation. So we pay really close attention to those. because at the end of the day, we work really hard to find an insight, and we want to make sure we show it as clearly as possible. So this is where we put in that extra 20% to make our insight very super clear. Okay, so that's the second point here. So the third point is about showing about scatter plots, like I mentioned before, as a tool, and that's really a tool for, it could be for both presentation and exploration. We would show a scatter plot, for instance, if it showed, say, a clear correlation. We could show that to an audience who would be able to then interpret that as, okay, these two variables are related. If we showed a scatter plot where the variables weren't, very well correlated, like an R square of like 0.4 or something like that, I don't know what our audience would really take away from that, right? So we're just showing a graph to show a graph to kind of say, these variables aren't really closely correlated. And that would be really the takeaway. So if that was your purpose, you could show that, but that might not be the best way to talk about what you're finding in your analysis. And to kind of give you hope that you can create beautiful graphics that say something, there are several packages available in R. So I've listed some of them here. I mean, the out of the box, plot function, I'll write it down here in the text chat, comes from the graphic package, but there's also we can create some sophisticated scatter plots using CAR, or some small multiple plots using lattice. And my favorite toolkit is using ggplot2, ggthemes, and ggviz. Those are really 3 packages that I use a lot in my visualization. And if we have time, we can work some problems out today using, if there is an interest. Has anybody used any other packages for visualization in R? Oh, Mike asked a good question. I spot Tableau icon below, right? So there's my Tableau. Yeah, so you can totally connect your work in R to other visualization software packages like Tableau. And we'll be using Tableau as part of the course in NYU Shanghai as well. It really depends. For instance, I could show a clustering model in Tableau and really visualize that data a lot better than I would be able to see that even in R. So, for instance, in Tableau, let's say I'm showing a bunch of points in there and how they're kind of clustered together. So you have, 3 or 4 clusters of data. I could actually mouse over the data and see what the data points those represent. So it's pretty cool stuff. So you can certainly connect those. And then there's even ways that you can do a little bit of modeling in Tableau these days. So Mike, I don't know if that kind of answers your it's not a question, but just your sentence, your comment. So there's other packages as well. I don't know, has anybody here used Plotly for any of your work? I'll write the name down. It's Plotly. Yeah, I mean, thanks for the responses. Yeah, I encourage everybody, if you don't mind, like just responding to some of the questions, even if you haven't. Just good for me to know that like you're around. But So Plotly is amazing if you want to create graphics that are interactive, and so you can actually use R to create a graph and then have it be web based, which is pretty great. And you can also use something called Shiny to create interactive graphics as well. So we have a lot of ways to extend, again, the basics that we're learning in R to other more sophisticated packages and ones that kind of get us out of working just on our machine and not having anybody interact with the things that we work with. All right. Just a few, I always like to bring this point up, this last point. So again, a lot of the work in session 5 has to do with, drawing some statistical visualizations, obviously. And so for histograms in particular, just want to make sure that you're aware that it's important to determine the number of breaks to separate the bins. And the bins are those are the kind of ranges on the x-axis. And we'll look at an example of that soon. And the other graph that we'll be creating is a box and whiskers plot. And there, just a reminder that that center line in the box and whiskers plot is the median, and we're able to see the interquartile range and also the range of data. So I have some code up here, and I just wanted us to look at this as a way of understanding how we plot using the simple plot function. And then we'll get to doing some code. But I thought, I don't always do this, but I thought I'd just do a little bit of a walkthrough. So you have the plot function, which comes from the graphic package. And here, what's assumed is I'm creating a scatter plot, okay? And in this case, I need to pass in 2 variables for a scatter plot. And so what data type do those variables need to be? Okay, so they need to be numeric. It doesn't matter if they're integers or not. It doesn't matter if they're positive or not, but they need to be numeric. Both variables do. And that's not always the case when you plot data. Sometimes you use what's called categorical variables to plot. So you might have something like region, and region equals Asia, right? Or region equals North America. And so you might color or encode your data using color based on a categorical variable. But in this case, we're just doing a simple scatter plot. Both our x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis, in quadrant 1, if you kind of remember that from geometry, needs to be numeric. The next parameter, and these parameters don't, besides the first 2, they don't go in any order. You can put them pretty much in any order. You need to have x and y kind of coming first. But after that, the next variable says main, or the parameter. Does anybody know what that means? Main. Yeah, that's my graph title. So guess what? All your graphs need to have titles. So if you think you're just plotting a graph with just x and y and that's it, no. So you need to make sure that you add the information that's relevant and that describes what you see. Okay. So that's the title for a graph. Good. So, and again, that's just a string. So you could pass in a variable here if you wanted to, that's of type, character, or you can actually literally write the name of the title. So XLab, what is XLab? The x-axis label. Perfect. And then you can guess what the Y-lab is. Y-lab is the y-axis label. Okay, Y-lab. Okay, so now I have you on the hook. You always have to have a title, an X label, and a Y label, okay? And these things, you're like, they come out of the box in Excel. Here, you have to really be explicit and specify them, okay? Otherwise, what's going to be the default for your X lab and your Y lab? Does anybody know what the default is? Yeah, Maria, perfect. The name of the column, and doesn't that look ugly? Right? It might be like, you know, movies, dollar signs, ticket sales. That would like you don't, and that's not something that's meant for like when you use visualization as presentation, right? The idea is that you want to have things that are very clear. And so, and somebody that isn't taking this class and visualizing data, they would have no idea what movies, dollar signs, ticket sales means. And so you want to use a descriptive name. Great. And then the next parameter I have is called frame.plot. Anybody know what that means? Jessica, it could be for exploration, yes. But I think as soon as you submit the work to me, I would say it's more in the presentation mode. The border on the graph. So what about the border on the graph? Oh, Prasanjit, yes, it removes the outer box. And so when I talked about the non-data elements, the frame plot is a non-data element. Putting a box around the entire plot, does it add to the message? All right. No, it doesn't add to the message at all, right? Because it has nothing to do with the data. It's not adding any description. I love what Mike's saying, less is more. And we definitely follow that sentiment here. And all of this is driven by a bunch of principles that we will learn a lot more about. Does anybody know what COL means? That's the last parameter here. Color for what? All right, so Kristen, right, the points in this case. Is here where I mentioned that we're making a scatter plot. So a scatter plot are going to show points, okay? They won't show bars or lines. And does anybody know what for CBA 3 is? Jessica, I like that. A greenish blue that I seem to like. It's totally true. So the Pantone color, it's called a modern cyan. That's the name of the color. And this is the hexadecimal code used to produce this color. So you could change this to all nines. So if say it was pound 9 and 6 nines, or if you changed it to all C's, the letter C, you get a gray color, okay? I prefer not using basic colors because they tend to look pretty ugly in R, except unless you're using like black or something. I would choose the specific color gray that you want. Again, there's like, if you wanted a dark gray, it's just 1, 2, 3, 4, 5, 6 nines. And you get like a nice deep dark gray. It might not be as harsh as a black. Now these are aesthetic features. And again, this number represents a hex code. So you can type it, type in hexadecimal codes into Google and get a whole bunch of them. And find one that you like using to kind of highlight important parts of your data. I use this color kind of as throughout all my work, and my recent book on data visualization. I was only allowed to pick one color from my publisher. So I came up with a style for how I wanted all my graphs to look. I used a particular font, which I'm sure you'll figure that out soon as you see more and more examples. And then I also use a particular color for any of my plots. So this just gives you a little bit of creativity and flexibility. We don't like to overuse color at all. So I would avoid using colors like red or like a basic blue or red. Pick a color that's kind of subtle, or stick to kind of gray, for a dark gray for your encodings. Yes, you'll know. I don't think you can copyright color or anything though. Okay, another thing that I wanted to speak about is I'm curious, how many people have created a Markdown document yet? Just give me a yes or no. I just want to know how much I should go over creating a Markdown document. Some people. All right, so if you haven't, let me know as well. I'll go over just like a quick run through of how you create it. And then, okay, good. So we're going to be creating a Markdown document today for our work, okay? And so let me go over quickly, or not so quickly, like at a normal pace, what it means. So we're going to, in the past, we've created documents that were of type .r. Oops. Of .r. Now we're going to be using RStudio and saying, file new Markdown document. And that's going to be of an extension .rmd. And we're going to write content using what's called a Markdown syntax. Not that difficult, but a little bit, there's a few important things for us to know. One is that when we create a Markdown document, we're able to kind of code and see the output right below our code, which is great. So we're able to kind of we don't have to use that console window. So, if you remember one of the first exercises, we used R as a calculator. We worked with a console window and then we've graduated to writing R scripts where we planned out our code. And now we're going to graduate to the next kind of contemporary type of file, which is an R Markdown. And you'll say, why did we even learn the console stuff? Well, because we're learning, and I want you to understand. You would have asked me, what's that console window for? If we only did work in Markdown. And there's points where I bet you use that console window maybe just to test something out, or to rerun a line of code, etc. So we're going to be creating a .rmd file, and we embed our R code using what's called these backticks. And I'm just writing it out in the text chat real quick. And the backtick is very important. This is not a single quote. This is a backtick, which is located above the tilde next to the number 1 sign. Okay. And we're going to put our code between those ticks, and everything else we can just write in English and use to kind of format our document to write descriptions about what we're doing and the like. So this is great. So you're doing analysis on a data set. You're able to kind of create a document, write up what you're working on. Think about everything that you do as maybe a mini blog post or a mini report, where you're saying, hey, I'm analyzing this data set. I'm looking to see, if there's any kind of correlation between X and Y. Let me import my data. Let me look at, the variables of interest, and let me visualize it, or run some summary statistics and then visualize it, vice versa. So that's kind of the point that I want you to get to in this class. Feel really comfortable doing that. Okay. And for every data set that you kind of work on and examine, again, like the unit of analysis in this course, at least, is usually a single data set that we're exploring and interpreting and learning more about. So to be able to do that as part of your process, really important to us in the program. And then the great thing is that we can render, if you see part 4, render our Markdown document into a PDF file or a Word document, or kind of what I've been doing for the course, a simple HTML file that then can be published to the web, which is great for sharing. It's also great for just showing, building a portfolio of some of the data projects that you've worked on. Really fun stuff. You can publish it on your site, have a little thing that says code and some of the code that you've written and projects you've done. So that's our Markdown. And so we're going to start with exercise 5.1. So I'm going to ask that, you can go to the materials tab. You can go to exercise 5.1. That brings up this exercise, and we're working with the movies.csv file here. And there's a few kind of tasks for each question. So we're going to, as always, get to know the data, import the data. We're going to build some scatter plots. and of, comparing two variables. Okay, and then we're going to look at how the data in our scatter plots is presented, and we're going to adjust the scales. We'll look at the relationship between movie tickets sold and sales. And then we'll move on to looking at scatter plots with lines, and you can add a regression line, and adding, again, those labels like titles, which is the thing that I went over before. We'll have some time to do some other plots, some histograms, some bar plots, and then we can move on to doing a little bit more work with visualization as well. I'll introduce you to some other aspects that have to do in exercise 6.1, where we can, I'm sorry, just trying to bring that up for you. .1 here, where we can do some more histograms, and also maybe use some advanced packages if you have them installed. We'll try doing that. So I'm going to keep my text chat open. I'm going to close my browser and open R. So I suggest you do the same, and that you have access to exercise 5.1 open. I have mine already done as a markdown file. So you can I'm just going to scroll down so you can kind of see what a markdown file looks like. So you see what we're trying to create. So generally, let's just look at this. Line 46 just shows some text written in English. And again, you'll see on line 48, there are my backticks. This means that I have a little R chunk embedded here, and then I have a plot, right? And then I can press this button this run button to actually run the code, and I see it in line. So that's pretty. So now I don't have to. In some cases, you might have saw the visualizations pop up in this plots box to the right, and that's a little bit like looking back and forth. So it's much better to have them kind of embedded with the code, because then I can go ahead and publish this with the charts and the code together. So this is just an example. So, and I have a lot of other stuff that's happening up here. I have a title, author. You can see all these things are different parameters that you can use, okay, for our markdown document. I'm not going to go over all of them. I get pretty obsessed with designing my markdown documents and using different types of themes to format how my code is presented when I, when I might what's called knit my markdown files. I haven't tested this code, so hopefully it's working. So when I knit these different files and they're presented, which I'll show you in a second. So you can see that, in particular, how you format your document and your graphs. Like you can change the different colors. You have the ability to change the bin width for your histograms, and just how the output looks a lot different. I can have grid lines. I can not have grid lines, and I can even have particular types of visualizations that are a little bit different and different formatted. So here I'm using the package called ggplot to take my data and format it and make it look like it was published in The Economist. Here I'm using ggplot, and the themes don't always work that well, but this looks like it's published in the Wall Street Journal. So you have the ability to kind of format what you want your data, how you want your data to be presented using a variety of themes in ggplot. So we'll get there. So let's, I'm going to close that. Let's begin by just creating a Markdown document. So File, New File, R, Markdown. And this is where a lot of the parameters that you saw in my my R Markdown document are defined. So you can give it a name. You can call this, exercise 5 demonstration. You can give it the author, and you can decide what you want the output to be. If you want it to be HTML, right? So that's hypertext markup language designed for the web, or if you want it as a PDF document, we should know what those are, or a Word document. So I would choose HTML, but you can also create like a PowerPoint presentation, or you could even create a shiny document that has interactive elements, or you might even have, a template that you're using. Let's keep it simple. We're going to create a Markdown document, and we're going to say OK. And do you notice that automatically these are this is the information that comes up. So I have my title separated by these 3 dashes. And again, you can go ahead and change any of this. But you see the output format as HTML document. Okay. This is a default piece of Markdown code that I'm asking you to kind of keep in your document. It says R setup. This is just a name that you give it. Setup is nothing special. Include equals false. Does anybody know what this means? Include equals false. It means when include the code in the output. So we're not going to include this code in the output. So when I knit this document, I got to save it first. So I'll call it exercise 3 demo. Oh, I went to the wrong one, excuse me. You'll see that this code, in any case, this code won't be available for you to in the output, okay? And what this is saying, knit R, it says this is the options for chunks. So everything that is separated by these backticks is known as an R chunk. And it's going to say echo equals true. That means that that we want the output to be shown, okay? So you can keep that line. And then this is just like gives you some guidance about what an R Markdown document is, how it shows you that you can, show and embed plots in your code. And each R chunk has an ability for you to actually press a play button and run that code, okay? And then you see that there's some explanations about what all this means. That echo equals false means that the code chunk won't be printed out, but the output will. So sometimes you can just print the output and you don't have to print out the code, okay? What I would suggest is after you kind of read through this, just delete lines 12 on. And now you can begin working on exercise 5, okay? So I'm going to give you, let's say, a few minutes to get everything oriented and go through the first couple questions. So what I like you to do is get to know the data and build a few scatter plots and redo those scatter plots by changing the scaling. So I'm going to give you just a few minutes. My time is 12:41. I'm going to give you until 12:50 just to concentrate, and so 9 minutes and work on exercise 5.1. And then I will go over a demonstration together. Okay, I think that might be the best way. So get as far as you can, and if you are done, just send me a ping. That would be great. You could even do that privately. Okay. So I'm going to mute my mic. Okay, so it's about that time. I just want to respond to Nee. I see that we have a little chat going on back and forth. Make sure that your version of R is the latest version. I was looking at Stack Overflow for you, and that seemed to be one of the solutions. Okay, everyone. So I've given you about like 9-10 minutes to do exercise 5, and I just wanted to walk you through kind of my approach to it, and you can kind of follow along. So again, I have a little bit more parameters in my R Markdown format. So I have that output as an HTML document, but I also am doing an HTML notebook, which I could show you probably pretty quickly. So exercise 5. Which allows me to do that formatting, and I'm able to do something that kind of looks a little, has like a nice table of contents, and I can just kind of click here, and then I can go and look at my code, kind of like I showed before, but I'm able to have it even more well formatted. I'll just exit out of that, and that's just what I was, what these different code options are here. Okay, in this HTML notebook, but you don't have to do that. Just wanted to show you what I was doing. Okay, so we're going to start with number 1. We're going to get to know our data. So here we're using the read R library. So, and I'm realizing that you're not able to see my screen. So let me just go back here, show my screen. Or are you? You're able to see my screen. I'm sorry. All right. Oh, thank you. Thank you. Oh, Jessica, that's a great point. If you are getting any errors with packages, just go ahead and go update those. Okay, so we're going to use the readr library. We're going to read in our movies.csv file using the read_csv function. We're going to assign that to a data frame table called movies. We can open and look at that data using the view function if we wanted to, but we know when we write scripts or any kind of code, we can't use the view function. We have to use it only at the console because it will throw an error when we try to compile or knit our entire report. We can look about how many variables are in the data frame. We can look at the names of the variables, and we can actually understand some of those different data types. We can look at the number of rows and columns. So this is all simple stuff that we do. But I'm just going to run this code so we can look at the output of that. Okay, and so I don't have that appearing inside my R Markdown file because you see I have R include equals false. So when I publish this as, say, an HTML document, none of this will be executed. So if you have R include is false, that means you're just going to see it in the console window. Okay. So here I have, clearly we've imported our data. We've looked at the number of columns. We've looked at those different names. Wonderful. We've also used the str function to see that we have some that are character, others are integers, and that we're dealing with 50 rows of data and 8 columns. And then I like to just, as I'm writing this, I always like to just use the view function at command line to say view movies, just to then just take a look at it. Okay. All right. So we can see that we have, the rank of each movie. We have the name of the movie, the release date, distributor, genre, the MPAA rating, the gross sales, and the tickets sold. Wonderful. Let's go back to exercise 5 and look at the scatter plots. So let's run this. And so what we're looking at is that we want to plot on the x-axis tickets sold and movies gross sales on the y-axis. And we're using that simple plot function that comes from the graphics package. So we don't have to say library graphics. We don't have to say that because we know it's kind of part of the default package. We could, though, to be explicit if you wanted to, okay? Just so you know where this plot function comes from. In addition, we are just, we're not adding any parameters. We're keeping this frame we're not labeling it. So this is just kind of simply out of the box what it looks like. And we notice that we really can't even read the values. And so this is where that we might want to adjust the scales. And so one way to do that is literally to create an R plot where we divide tickets sold by 1,000 and gross sales by 1,000. And we can see that the output of that plot, it's going to look a little bit better. And we know that there's going to be a perfect relationship here, right, between tickets sold and gross sales. So we know what to expect in the data. And that's why I have you work on this one, because I don't want things to be kind of unexpected at this point. So another thing here, notice in my R chunk, it just says R, and that's it, in between the curly brackets. That means that I'm able to see the input and the output, and both will be published, okay, when I knit my document. So Jason, yeah, I am creating a chunk for each chart. So anytime I want to kind of create a piece of R code, let's say it's above B, I'll just call it like, this is example, and then I would say insert R. And here I might say like, I might do another plot, okay? And the output would come below. I like doing it that way because then I'm dealing with literally chunks of code, and and again, for teaching purposes, so we go kind of like step by step. At the end, when you're doing this, you might just have one chunk that visualizes the data in the perfect way, right? So we've gone from this example all the way to one that's going to be a lot more readable. Usually every time a piece of R code does like a function for us, that's like giving us a function like a plot or something, I usually do that as a separate chunk. So in item number C, we're going to redo that scatter plot and divide by 100,000 now. So again, using the plot function as in our code chunk, just dividing this variable tickets sold by 100,000 and gross sales by 100,000. And it's becoming a lot more readable, right? And we'll just do that one more time. And now we're going to divide by 1,000,000. Now it looks like we actually have a scale that is a lot easier to interpret. And now we can say that we're looking at gross sales and tickets sold in millions. Okay, so now we've picked a denomination that is easier for us to look at. And now we can refine that scatter plot. So what I'm doing here, I'm going to expand my screen. So I've done a few things. I've created a variable called movies tickets sold millions, and I'm assigning this computation to that. So now I'm creating a new column in my data frame. That's just the normalized data, just so I never have to do it again. Okay, so that's going to add a new column, 2 new columns here. And then after I do that, I'm going to plot using those 2 new variables I've created, those 2 new vectors I've created. And I'm going to go ahead and format my chart to have not only my normalized X and Y variables, but also a title, a label, number of tickets sold in millions, an X label, a Y label, gross ticket sales in millions of USD, and set my frame plot to false, and set my color to this modern cyan. Run that code, and you can see that this It's looking a lot neater than the previous one. I'm going to pause for a question. So Sheil says, we accidentally put the original column names instead of underscore millions. Will the original column get overwritten? Absolutely. And the original column that you've imported into R, your CSV file will remain untouched. So all you have to do is re-import that CSV file. Make sense? Yep. Perfect. Now, the next question I have for you is, what is the correlation between tickets sold and ticket sales? Is this expected? And of course, you'll notice that there is a perfect correlation, but I will run this. Thanks, Jason. Yes. So 1, right? So there's a perfect correlation between these two variables. And this is expected. Now I want to get to doing some scatter plots with lines. And let's just talk a little bit about the parameters that we're using. So we're, again, just using the basic plot function. And you'll see how as you learn more advanced functions to plot data, it's sometimes handy just to use a simple function like plot just to see your data quickly, again, and to use that for some of your exploration. So here I'm taking that variable tickets that I normalized as my X, my Y, those stay the same. I'm using type B, and that's going to give me my regression line, okay? When I add this parameter, you say, how did you get that? So if you say question mark plot and look at the help file on the right-hand side of the screen, I'll adjust it for you. You'll see that you have all these types. So if you use the type parameter, you can get P for points, L for lines, B for both, C for and sometimes it's not as literal as you think because it really depends on your data. Okay, but you can try some of these out. Again, it depends on your data. So even though it says that you're going to get, a histogram, you might not get one. Okay, because it depends on your data. Because we know that a histogram, we'd only need one parameter for our x-axis. We don't plot a histogram using x and y plotting. Okay, so let's. So that's how you always, and that's where the usefulness of that help file comes in. When you're like, you want to modify a parameter that's a function, and now you know that functions can take multiple parameters. Passing in our x and y. Now we've passed in our type. I'm going to run this for you, just so you can see. So I'm getting both, even though I picked B, and B was going to give me both, right? Not even though, excuse me, I picked B to give me both a regression line, and points. Would I always get a straight line when I picked B? If I'm adding a line to a scatter plot, would it always be? It's a question to think about. So if you plotted two variables that were so when you show a linear regression, this it will show a line, but the points can be scattered all over the place, and the slope of that line may be different. Okay. But when you add B for a line, it's always going to be a straight line. The slope will change. And it doesn't imply that there's a correlation just because you put a line on the chart. Here it's a perfect correlation. So I see a line through all the points. Okay. Of course, this one doesn't have a frame plot, and I chose a color. But let me choose a different color. I mentioned that one that I like using for a dark gray. So it's 1, 2, 3, 4, 5, 6 nines. I can change that And you can see how my colors changed on the chart. Okay. You know, if you wanted even a lighter gray, 1, 2, 3, 4, 5, 6 C's, and you'll get used to kind of using hexadecimal, but you can see how you can certainly customize that. And then I just use the undo button, which is really nice, and I can get back to where I was with modern cyan. Okay. So next, we're going to look at creating a box plot. So there's a function called box plot. And if you wanted to learn more about that, and we should probably do this now, question marks box plot. And we can see what those different arguments are for this. So this is the full function. So we are able to modify a lot of these parameters, whether we want what color we want, you know, all this stuff. Whether we want a horizontal box plot or a vertical one, we can set that to true or false, okay? And then you're going to say, well, what does this mean? What does this variable mean, or this parameter? And anytime you want to, those are called arguments. And you can look and see what the arguments actually mean. So that's kind of a first step to understanding the full capabilities of say, a box plot or whatever visualization you're choosing. So let's go to here. So we're just going to do the basic one. We're going to show, and we're only showing, a box plot only shows one variable, right? We're looking at one column of data here. Scatter plot, we're comparing two columns of data. Here we're looking at one. I'm just going to look at gross sales in millions. And I'm going to get rid of that frame around the plot, and I'm going to change the color. Okay, and at this point, make my screen bigger for you. So how would I interpret what's happening here? How would I interpret this chart? Well, we can see that that we have one observation. I can compare it with the average. I also can see I have one observation that has grossed a significant amount more. We call that an outlier here. We can also see that what the median is, and again then the range. And sometimes I even like to, at this point, I would take this variable, because I'd be curious what the actual value is for that median, and I might say, median just to see, okay, that's 27, just so it helps me interpret the chart. It might not be clear that that's 27 from the scaling, right? And so we might consider removing the outlier, we might not. Again, if we're just exploring our data. Good. So I can also compare it with the average, Hibika. That's great. So I could do the same thing. Instead of saying median, I could use the mean function and get the mean, which is a little less than double of the median in this case. So now if I wanted to do another type of box plot, I could do a horizontal box plot, and that's where I use this parameter, horizontal equals true. And then I can also add a title, just like I would in all my plots. Set the frame to false. Able to see that. To me, that could look a little bit more clearer, changing the orientation of the box plot, for instance. Okay. I can also now begin creating other visualizations, histogram. So let's look at what I'm doing here. I'm going to do a histogram of genre. And what is genre? So right now I have genre. How am I going to do a histogram of genre? And right now you see that genre is categorical data. But I kind of want to know the frequencies, right, of the different types of genres. So, the best use of a box plot is really for you to. It really gives you, if you're looking at a single vector or single variable, or you can do a box plot of every single variable in your data set, as long as it's numeric. And actually, just it allows you to see the range. It allows you to see some outliers and the median really, really quickly. Okay. So I'm back on genre here, and I mentioned that I'm trying to create a histogram with categorical data. And so what I need to do is I need to convert that to a factor variable. So now I can associate a single number with a single genre. And then I can easily create a histogram. Otherwise, I wouldn't be able to create a histogram with data of type character, because we know the hist function, HIS, takes data that's of type numeric. So I might do something that is a little tricky here, but I would create another variable called genre factor, okay, and I'd convert movies, the genre variable, to a factor variable. And I know that you've done this in a few of the lessons. And then when it's a factor variable, to actually cast it as a numeric, because I know how it has a number associated with it, and pass that into my histogram function. And then all the same things in terms of like adding labels. Of course, we only have an X label here for histogram. Why? Because we're only graphing one variable. Okay, so here I have 8 different, so these are all the 8 different, genre types. And so 1 represents one genre type, 2 represents 2 genre type, a second genre type, 3, 4, etc. So, for instance, I could So if I use the levels function here, I'm just doing this in the console window, I can see what the levels are, and I have 8, right? Action, adventure, black comedy, comedy, drama, horror, romantic comedy, and thriller suspense. So now each one of these has a number associated with it, in addition to a character string. Okay. Any questions on that part? How do I label the categories? So we'll get to that. We wouldn't want to label anything here in a histogram because we're showing frequencies, okay? And it looks kind of like a bar chart, but it's actually not. We're just measuring the frequency of the number of observations that are associated with 1, okay? With the number 1, which is actually action. But we can get there. Other thing, so Maria, I'll get back to you on that one. Border, I say border equals this hexadecimal code. Does anybody know what that color is? Yeah, it's white. So if I change this, let's say to gray, you could see a border in between. I don't know if you see that in between the bins. Each one of these between 1 and, let's say, 1.9 or whatever, this would be 1 bin, and then there's that little gray. I like using white because I think it makes it clearer, using white space instead of gray. So watch it closely, see how the white kind of pops. Okay. Next up, we have, we're looking at a histogram that's just showing the gross sales in millions and looking at the default bin size that the histogram produces. So a lot of movies are between 0 and say 49. And we see this, we know that there is an outlier out here, right? That one movie that had very high gross sales. Okay, so we can see kind of like the shape of our data here, but we can change the bin size so we can make this a little bit more discrete. It doesn't have to be 0 to 49, 50 to 99 as the bin size. So R by default determines the bin size for you, but we use this function called breaks here to say that we want, say, 10 number of breaks, and it really has to do with understanding the shape of your data. So here, if we have 10 breaks, you notice that I get a lot more detail here. Okay, and that might be helpful. So I might want to know more, like, okay, between like 0 and 20, like, there's like, say, 15, like over 15 frequency count there of movies in that range, and you can keep kind of going, but it gives me a lot more detail. If I did like something like 20, R might not even process that, right? I mean, you might get like, but I don't know if I'm getting actually 20 here. Okay, so it will divide it into the number of logical bins. Even if you put like 1,000, it's not necessarily going to do 1,000. I'll do 200 just to show you kind of what starts happening there. As you increase bin size, you lose. I think you lose something. Okay, so but you don't want too small of a bin size either, because then you're not seeing much detail. All right. So it really depends on your data on how you determine the bin size. I think if you have a histogram with like 2 bins, you probably should increase the bin size. If you have it with like 40 bins, it really depends how big your data is and how dispersed it is. Okay. If you have a high standard deviation, for instance, you might want to have a larger bin size just to show that deviation. There's not a minimum count. Some bins actually had 0. Okay, so if you have too many bins that have 0, that could be a problem too, just visually how that might look. And then I asked you to do a histogram of tickets sold and to try different bin numbers. So I'll just show a few. So I'm using tickets sold in millions. I have my X label. I have my title. I've chose my color, and I have a border. Okay, that I've set to white. And here, so I'm comparing this to having 15 breaks. Okay, so let's just run these two. If you do 2 graphs at once, you'll see the first one and then the second one. So I need to scroll down a little bit. Okay, so this is the first one with the default number of bins, and this gives me a little bit more detail. And I'm using a base HIS function. Okay, I don't get a lot of customization with this function. So sometimes I'll get this, histogram that comes out here. I don't have too much control over the scaling. As we get using more sophisticated packages, we have much more control over scaling. So here, I think Maria asked about labeling. We'll do a little bit of labeling here of actually adding the frequency count on top of the bars. Okay, so here we're using the hist function. We pass in our X variable. We chose, let's say, 15 breaks, and we say labels equals true. Okay, that's the only difference here. So I run this code chunk, and you can see now that I have, I'll make it a little bit bigger for you so you can see. Sometimes it will look like your data is cut off. You just have to kind of expand the chart. Alrighty. And I like to show that because then you could see how many bins actually have 0. And so you kind of want to, minimize those that have 0, but still providing enough detail. Okay, so I can't give you, there's not a single answer. It really depends on your data. Okay, let's do a bar plot, okay, of the movie genres as proportions of the whole. Okay, this is kind of a fun thing, and this is Maria where we can do some labeling. So instead of using a histogram, we're going to use something called a bar plot. And what we're going to do is we're going to create kind of like a proportion table that shows you the proportion of the number of movies that are of a certain genre. So we know we have 8 genres. So we kind of like the whole is, 50 movies. What proportion are horror? Okay. What proportion are suspense? That's what we want to know here. Okay. So we're using a function called proportion table. And then we're first making a table of all the genres. And then we're using this proportion table function. So this is just something introducing you to that's new. And you can, if you're curious about what this is, of course, you can go to the help file, and this is where we can look. It's a function that takes a data of type table. Okay, so that's why we've made our movies genre a table, and then we're able to kind of look at the proportions. Exactly what I said there. We run this, and so that's we see that drama takes up the highest proportion, but what's wrong here? It's like not every bar is labeled, and so that's also a little disconcerting because I don't know what these mean, and it's not like I can't mouse it over, so I can enlarge. Great, but I'm missing that last one, or maybe I think I'm missing the last one there still. So we want to make sure that we can control what the labels are and that they actually show up. So one of the things I can do is I can change the font size of the labels for the x-axis and add the label names. So I'll add them exactly how I want them written. So just a few things. So I have my, I just wanted to show you this code, the table's genre code. So you know if I take a variable and I convert it to a table, what it looks like. So you'll get something like that, just the counts for each genre type. And then I'm going to do my bar plot same way. And then I use this CEX names, and that sets my font size. Okay. We won't go into this so much, but you can increase this or decrease it, and it'll get larger or smaller. Then I can use the names argument and pass in a vector. We're used to writing these vectors, right, using the combine function, and a vector of length 8 because we want to make sure that all those bars are labeled. And then our other parameters here for our bar plot, which is just our color of our bars and the border. Okay, so here I have each one labeled. So you see the kind of customization that is sometimes required to aid in readability and interpretability. So kind of base functions for visualization are limited. That's a takeaway. And so we need to make sure that we add those parameters that allow us to label our bars appropriately and label our data. Okay, so we know what it means. As we get more advanced, we could just mouse over our bar and it will tell us what that bar means. But again, labels are really good when we're kind of showing categorical data. We want to know what those categories are. I was going to do an advanced demonstration if you're up for it. So a few things. I mentioned that there's the car library. You might have this installed. But this is we can use a function called scatter plot. And this will show us a scatter plot with box plots, just as a way to good for exploring your data a little bit. So you don't have to. You can kind of see the box plots of each of the x and y variables, and then you can also see a nice regression line and that perfect correlation. Okay, and then I can also add a main. I just wrote gross X tickets, but you'd create something that was more descriptive. We can also use a package called ggviz, and I'm just going to show you an example of a ggviz, but it's we will go over it in the in-class session on how to use this package if it's of interest to you. But it essentially allows us to create a what's called a shiny-like visualization, and you can see, you know, it allows me to like download my plot right away, and you can even add interaction to this type of chart. And then kind of the one that you can also try just for fun. And what I'm going to do is I'm going to cut and paste this code in the text chat. But if you have this ggplot2 package installed, you can use the ggplot package to create a lot of different charts. And how it works, in just a few minutes, I'll go over how it works. We require the ggplot2 library, and then we use a function called ggplot to first pass in this case, our data frame and the data that we're working with, and then our x and our y variables using this AES function, which stands for aesthetics. Okay, so this is kind of like your data frame. These are the x and y variables. And then we use this plus operator, not for addition, but for more like concatenation of a function. So we're adding a function called geom point, indicating that we want a point chart. Okay, so, or a scatter plot, and we can set the colors and the borders. So if I run this, this is kind of what a ggplot looks like out of the box. And you know that we need to take time to modify the aesthetic parameters, such as the title and X and Y labels. But you can also, instead of using GG point, you can choose geom bar, okay, or geom box plot. So you'll see that you have the option to choose all these different. You can choose an area plot and other functions. In this case, of course, we're just using the point for a scatter plot. But there are a lot of. This is where you specify the chart type, but you still use the same base function. Here's my data, my x and y variables, but you might be just using one variable, and then you choose your particular type of chart. And then if you wanted to do some special formatting, you not only use the ggplot2 function, but the ggthemes function. Again, to go over this, we call ggplot, we pass in our data, we modify the aesthetic parameters, which are really just our x and y variables. We say we want a point chart, so we say plus geom point, and we keep that, we don't pass in any parameters there. And then we use a function called labs, which we can specify a title, a subtitle, a caption. So now we can even cite where our data is from, okay, and specify the x-axis label, just you say by saying x equals, and the y-axis label. So let's do this first. And you'll see that now I have a good template for how I want my charts to look. If I want to add another, say, aesthetic value, I don't know how many people of you know Edward Tufte, but I can say plus theme underscore Tufte. And that will kind of make my chart look like it follows the Edward Tufte aesthetics for visualization. If I run this, you can see kind of what that means. So it takes away a lot of the grid lines, a lot of his aesthetics. He uses more of a, can I paste that to the chat? Yeah, sure. So let me paste this to the chat. you see that it's a lot. But once you get the basics of each component that's required, you can reuse this code. I'm going to change this now to another theme. So instead of Tufty, maybe I'll choose Google Docs. You can have your data look like that it was generated in Google Docs. And see how that theme works. And as long as you have GG themes installed, you can also choose, I chose Economist before, but you could even choose Excel. You can make there's a lot of different themes that you can choose from. Stephen Few or 538 you might have heard of. You can make your chart look like it was created on the 538 website. And, we'll do one more for funsies. You could even it's from Stata. For Stephen Few, who is an expert in data visualization. So, but you notice theme Few has a border around it, so you might not like that, so you can still modify some parameters. Anyway, I hope that you might have to update your GG themes package, Jason. Some of the themes don't always load. It comes from GG themes, though. Yeah. Well, I hope this was useful. Kind of wanted to inspire you to think about how we practice using a lot of different functions today to visualize our data, and knowing that we're kind of not just limited to doing histograms and box plots, but we can do bar plots. We can change our data by using that tables function. So we can change, say, categorical data and show it as a proportion of a whole. We did that by looking at the movies genre. And then we also looked at how to use some more advanced functions like ggplot, ggplot that comes from the ggplot2 package, and also GG themes. So if you want me, so there's a question, can we get this markdown document? Yeah, I have some other stuff in here, but and I won't edit it. But what I'll do is I can go ahead and knit this, and I'll give it to you. So Tong, it looks like that we're out of time. So we won't be talking about that today, but feel free if you have questions about it. I can certainly share that with you, and I'll go ahead and publish this to our pubs, because I'd rather just get you the URL right now. And this is called exercise 5.1s. Okay, so you can see this. And I have most of the code here. I didn't hide much from you. Actually, you should have most of it here to see. So let me know if you have questions. I can always also send you guys the RMD file, but it should give you enough to go on. Thank you so much. Again, if you have questions, feel free to reach out. And I'm really looking forward to seeing you in class on May 16th. We get a whole day together, and so we'll do more visualization. We'll do some stuff in GGViz, some stuff in Shiny, and it will be really interactive. So drink some coffee in the morning because we'll be doing 6 hours of R, but it will definitely get you to a great point. And I appreciate your participation in these sessions and look forward to seeing you soon. Thanks. You're very welcome. Okay, take care, everyone.